Good afternoon, sir. Good afternoon, my colleagues. My name is Akin Otoyinloju, and I'm here to present a seminar on explain the importance of photostability testing of drug and its application. So, we define photostability. Photostability refers to the ability of a substance, such as chemical compound, pharmaceutical drugs, or material, to resist degradation or maintain its chemical, physical, or functional property when exposed to light, particularly ultraviolet or visible light. Then we talk about why photostability testing matters in pharmaceuticals. Talk about ensuring drug safety and efficacy. Exposure to light can degrade active pharmaceutical ingredients, leading to reduced potency or formation of toxic byproducts. Photostability testing identifies this risk to ensure the drugs remain safe and effective throughout its shelf life. Then regulatory compliance. Photostability testing is mandated by regulatory bodies like the International Councils of Amazon, the ICH, under the guideline of QIB to gain marketing approval. Then the ICH guideline requires testing under controlled light conditions to assess drug stability, ensuring compliance with global standards of pharmaceuticals. Then we have, under that again, we have prevent economic loss. Identify photostability issue early, avoid costly reformulation, product recalls, or batch failure. Unstable drug may fail quality control or degrade before reaching consumers, leading to financial loss and reputational damage for manufacturers. Then support shelf life determination. Photostability testing helps establish a drug shelf life under real-world light exposure condition. By stimulating light exposure during storage and use, testing ensures the drugs remain stable and effective until its expiry date. Mechanism of drug photodegradation. We have direct photodegradation. In this process, the molecule have a photon with sufficient energy to promote an electron to an excited state. The excited molecule may undergo bond rearrangement or other reaction leading to degradation. For example, in polymers like polyethylene, ultraviolet absorption can break carbon to carbon bond, reducing molecule with mechanical strength. Then we have indirect photodegradation. This involves the generation of reactive oxygen species such as hydroxyl radicals or singlet oxygen through photosynthesis. Molecules that absorb light and transfer energy to oxygen or other molecules. These ROS, that is reactive oxygen species, then react with the target materials, causing oxidation degradation. This mechanism is common in aquatic environment where dissolved organic matters act as a photosynthesis. Then factor influencing photodegradation. We have light, wavelength, and intensity. The ultraviolet light 200 to 400 nanometer is most effective due to its high energy, capable of breaking chemical bonds, shorter wavelength. Then we have the material property itself. Chlorophores, functional groups that absorb light, determines the material susceptibility to photodegradation. For instance, aromatic compound with conjugate system are more prone to photodegradation than aliphatic compound. Then we have environmental condition. Oxygen accelerates photodegradation by reacting with the excited molecule or radicals, forming peroxide or other degradation products. Temperature and humidity also influence reaction rates. Then we have presence of catalyst. Then we go to application and implication. Application and implication. Photodegradation has both benefit and detrimental effect. In the environmental impact, in nature, photodegradation helps break down pollutants such as pesticide and plastic in water and soil, reducing their persistence. However, it can also produce harmful byproducts such as microplastics or toxic intermediates. Then material degradation. In industry, photodegradation causes fading, replacement or loss of function in products like plastic, textile and coating. This necessary the use of stabilizer to extend product lifespan. Then we have photocatalyst. Control degradation in harnessed in technology like photocatalyst, water purification where semiconductor like oxygen degrade organic pollutants under ultraviolet light. Then factors influencing photostability: molecule structure and chemical composition. The chemical structure of a compound significantly affects its photostability. Molecule with conjugate system, double bond, or aromatic ring are more prone to absorbing light energy, leading to photochemical reactions such as oxidation, isomerization, or cleavage. For instance, drugs with chlorophos, light absorbing group, are more susceptible to photodegradation. The presence of electron donating or electron withdrawal group can also influence the molecule reactivity under light exposure. For example, the photodegradation of nifedipine, a calcium channel blocker, is attributed to its dihydropyridine ring, which absorbs ultraviolet light. Then we have wavelength and intensity of light. The wavelength and intensity of the light sources are critical determinants of photostability. The ultraviolet light 200 to 400 nanometer is more energetic and likely to cause photodegradation compared to visible light of 400 to 700 nanometer. The extent of the degradation depends on the overlap between the light source emission spectrum and the compound's absorption spectrum. High intensity light sources, such as those used in accelerated stability testing, can accelerate photodegradation. The example, the International Conference of Harmonization guidelines specifically exposed to 1.2 million arc hours of visible light and 200 hours of UV light for photostability testing. Then we have environmental condition. Environmental factors such as temperature, humidity, and oxygen availability influence photostability. Higher temperature can enhance the rate of photochemical reaction by increasing molecule collision, while oxygen can participate in photooxidation process, forming reactive oxygen species that degrade the compound. Humidity may facilitate hydrolytic reaction in the presence of light, particularly for hygroscopic material. Then we have example riboflavin, that is vitamin B2, undergoes photooxidation in the presence of oxygen, leading to the formation of lumichrome. Then we have formulation and packaging. The formulation of a product include excipient and pH can either stabilize or destabilize the compound under light exposure. Excipients such as antioxidants, e.g. ascorbic acid, as vitamin C, or UV absorber can enhance photostability, while some excipients may act as photosynthesize, promoting degradation. Packaging materials such as amber glass or opaque container can protect compound by filtering UV and visible light. For example, amber glass bears significantly reduce the photodegradation of fluoroquinolones antibiotics compared to clear glass. Then we have the physical state of the compound. The physical state, solid, liquid, or solution affect photostability compound. Compounds in solution are generally more susceptible to photodegradation due to increased molecular mobility and interaction with light. In contrast, crystalline solids may exhibit greater photostability due to their rigid lattice structure, although surface defects can still allow degradation. Then we have example, amorphous form of drugs like indomethacin are less photostable than other crystalline counterparts. Then presence of photosynthesizer such as a certain dyes, pigments, or impurities can absorb light and transfer energy to the compounds or generate reactive species, accelerating photodegradation. For example, trace metal ions or residue solvents in the formulation can act as catalysts for photochemicals. Example, chlorophyll naba extract can act as a photosynthesizer, promoting the degradation of active ingredients. Then we talk about the regulatory. That's where we have the International Council of Ammunition Techniques. Then the testing methodology. We have light source. The ICH guidelines specifies light source that approximately sunlight, such as number one, a cool white fluorescent lamp, option two, a xenon of metal halide lamp that produce a spectrum similar to daylight. Then we have cleaning chemical actinometry is recommended to verify adequate light exposure, particularly for UV light. Then we have sample presentation, that is drug substance. Samples are typically presented as thin layer in aluminum pan or glass dishes lined with aluminum foil to minimize deflection and ensure uniform exposure. Drug product testing is conducted sequentially. Fully exposed products and products in intermediate packaging and products in marketing packaging. Then we have the dark control. Sample wrapped in aluminum foil are included to evaluate thermal induced change. Then we have the procedure. First, degradation, then confirmatory testing. We'll talk about the analysis and judgment of the result. The analytical method. Validated stability indicating method are used to detect degradation products and assess change in potency. Then we will talk about the acceptance criteria. Results are evaluated in this specification to determine if light exposure causes unaccepted change, if degradation is observed, protective packaging or labeling. Okay, and then we talk about the best practice and challenge. Then we are talking about calibration, regular calibration of light sources, radiometers, and loss meter is essential to ensure compliance with ICH. Then we have the environmental control, that is, the temperature and humidity must be controlled to isolate light-induced effects. Then we have the challenges, variability in light source, variability in light source, sample positioning and packaging interaction can affect results. Standardizing condition and using automated chamber mitigate this issue. Then we talk about the importance of photostability testing. Importance of photostability testing. Number one, to ensure product safety and efficacy. Number two, regulatory compliance. Number three, guiding packaging and storage decision. For preventing economic loss. Number five, we have supporting formulation development. Method of photostability testing. Objective: photostability testing determines the substability of a product to degradation under light exposure, particularly UV and visible light. which may affect the efficacy, safety, or shelf life. Then equipment, we have the photostability chamber, the light detector, temperature control, and sample holder. Then we talk about the method: prepare the sample in their final packaging, and include control sample wrapped in aluminum foil. Then for solid dosage from e.g. tablet, spread sample in a simple layer to ensure uniform exposure of light. Then light exposure condition, we have a cool white fluorescent, about this earlier, with minimal loss hours of visible light and integrated near UV energy of 200 watt. Then in option 2, a combination of separate UV and visible light source achieving equivalent exposure level. Then we talk about the testing procedure too. Place sample in a dark control in the photostability chamber exposed to the same specific light dose, ensuring uniformity. Then we talk about the concentration, what to consider. Then we have the light source variability, ensure the light source spectrum matches regulatory requirements as different source. Packaging effect, the product sensitivity and regulatory compliance. Let's talk application in pharmaceutical industry. One, ensuring drug product stability and shelf life, guiding packaging material selection, regulatory compliance and market approval, formulation development and optimization, risk assessment for patient safety, then supporting use stability study. Then talk about the challenges and future perspective. Then the challenges, we have variability in light source and testing condition, complexities of sample matrix. Then we talk about the regulatory compliance and interpretation, time and cost of constraints. Then limited understanding of photodegradation mechanism. And what are the future perspective? Advanced analytical techniques, computational modeling and simulation, standardized light source and protocols, smart packaging solution. Then in conclusion, photostability testing is a criteria component of pharmaceutical development, ensuring that drug substance and products maintain their quality, safety, and efficacy when exposed to light during manufacturing, storage, and distribution.
Thank you. Any question or contribution? No question. Okay, ask.
What do you mean by excipients?
Excipients. If you want to produce medicine, apart from the active pharmaceutical ingredients, we have excipients like coloring. We have coloring additive like coloring, then preservatives, sweetener. Those are what we mean by excipients.
Any other thing you add in the formulation apart from the active ingredient is part of excipients. Is that correct? All right. Thank you very much. Thank you very much.